In this notebook, we're going to illustrate the idea of a normal form. And the example that I'm going to be working through is taken from a MongoDB Applied Design Patterns book, which MongoDB is a non-relational database, but nonetheless. So the idea is starting with, we want a database where we have someone's name, their phone number, and zip code. And so it might look like this right here. Let's see. Where we have Rick, Mike, and Jenny. They all have a single phone number and a zip code. But the problem with that is people might have multiple phone numbers. And so if we do a solution like this, where we have Rick with one phone number, but Mike has two phone numbers in the single cell, and Jenny has two phone numbers in a single cell. Now, this is no longer in first normal form, because according to our definition here, first normal form is any data that's tabular with each row-column intersection, or a cell, containing exactly one value. And we see in these cells we have two values. So another solution we could come up with is, well, we could say we could have two columns, one for phone number 0 and one for phone number 1. This has a drawback of we now have a null field here, but we haven't really solved our problem because someone might have more than two phone numbers. I have a work number, a home phone number, a cell phone number, and so this solution probably isn't getting to the general solution that we're interested in. So here we have a form where we have multiple entries, but we now have, we've introduced, and so we have, if any cell, intersection of row and column, we only have a single entry, but we've introduced the opportunity for data inconsistency because we have two rows for Mike and Jenny with their name, their phone number, and their zip code. And so I might have in row 2 here a zip code of 30062, and on the next entry for Mike I'd have a 30063. Well, which one's right? So this duplication has introduced the opportunity for us to have data inconsistencies. So here's a normal form solution, and it's achieved by creating two databases. In our first database, we have a name and a zip code and a unique identifier for each of these people, Rick, Mike, Jenny. And then we have a phone number table where we have the phone number and we have the ID that refers to this unique identifier in the person table. And so here we see we have identifier 2 for Mike and a phone number, identifier 2 for Mike and a different phone number, an identifier 3 for Jenny, a phone number, an identifier 3 for Jenny and a different phone number. So given this idea, let's implement this in Python. And I'm going to just use a SQLite. I'm going to make an in-memory database. And what I'm going to do is I'm going to create a table, if it doesn't already exist, called persons. I'm going to create a column called ID, which will be an integer, and I'm going to use this as a primary key. The primary key will enforce the idea of uniqueness, that this integer identifier has to be unique in this table. Then I'm going to have a name, which is a text, and I'm going to have zip code that's a text. And then I'm going to do an execute many to insert into the persons table the values of ID, name, and zip code for Rick, Mike, and Jenny. Then I'm going to create a table named contacts, which will have an integer ID, integer, and a phone number, which will be a text. And I should probably have this here, but I'm not. That contact ID is going to be a foreign key referring to ID in the person table. And then I'm going to insert these phone numbers. So let's run this far. And then we can do a select let's see, let's just make this a little more readable. So because I've split my data between columns, to bring it back together, I need to do a join. And so I'm going to join on the person's ID is equal to the contact's contact ID. And as I run this, and then I do a fetch all, you can see I now have my data with Rick, his zip code, and his phone number, the 2 entries for Mike, the 2 entries for Jenny. We no longer have the opportunity for data inconsistency because we only have one place where the name and zip code is stored and not 2 rows like we did in our previous solution. If we just look at what persons looks like, we have our unique identifier, our name, and our zip code. And if we look at what our phone number contacts looks like, let's just copy and paste that. You see we have these integers, which are references to the contacts table, and then our phone numbers. Well, we can insert another person. In this case, I'm not providing a zip code. And so then when I query everyone, I have a zip code of none for Ziggy, which is going to be null in the SQLite database. It's converted to none when it's read into Python. Now let me try to insert another person, the Thin White Duke, and I'm going to use the identifier 4, and when I run that, I get an integrity error because this primary key that I declared here for the ID has a uniqueness constraint. So I need to change that to like 5. And then I'm able to add them into the database.